Well, hello everyone. Welcome back to Adrian's Digital Basement 2. We are back on the Mystery Jack television. This is actually part 4 in the series, and I never expected this to turn into such a long and in-depth series on repairing televisions, or at least this television. I recommend watching the first 3 parts if you haven't seen those yet, because it's been a little bit of an adventure trying to figure out what's wrong with this set. To do a quick recap, when I first got this TV, it had a couple quarter-inch jacks installed in the side of the set, and the TV wasn't working. Didn't really know what the deal was with that, so I opened it up to investigate. Well, it turned out that someone had connected these jacks directly to the deflection yoke. Maybe they were trying to turn this into an oscilloscope, not too sure about that. But the set was totally dead and wouldn't even power up at all, so there's no way these jacks would have done anything anyways. This TV ultimately is pretty boring. It's just a 13-inch run-of-the-mill Magnavox Philips set that has composite video input and no RGB mod capability that I'm aware of, and well, not much else to say about it. In that part 1 series, once I figured out what they had done with the deflection yoke, I got that all hooked back up and the set still didn't work. It turned out that the horizontal output transistor was actually shorted, but in a weird way. But when it would go short, the B+, which is the main power supply for the whole set, wouldn't even run. So the set would just sort of sit there and make a clicking noise, and we wouldn't be able to turn it on even. Once I figured out in part 1 that the horizontal output transistor was the fault, in part 2, I took a spare horizontal output transistor from another Philips TV set, installed it into the board, tried to get it working, but things were just not working correctly. And unfortunately, after just a few seconds of operating, and the set wasn't even really running properly, it blew and destroyed the horizontal output transistor that I installed. So in part 3, I tried to get to the bottom of exactly what was wrong with the set, and I thought maybe there was a problem with the flyback transformer, which is right here, or maybe the deflection yoke. So I used some of the special tools that I have to try to diagnose those, just to check to see if those were good or not. Well, it turned out that they were actually fine. So I put the flyback back in the board, and I needed another horizontal output transistor, so I found this scrap TV set where it had a horizontal output transistor that should work, had the same footprint and the size and whatnot, with the one difference being that this one had an integrated damper diode, and this Philips TV actually had an external damper diode. So a little bit of research later, I figured out that all I had to do was take the damper diode off the board, install the horizontal output transistor, and then I slowly started bringing up this set. Well, wouldn't you know it, this was all in part 3. The set actually came to life. It was generating high voltage, but it turned out we have another fault, and it was written on the front of the set. There's no vertical deflection. So while we get a picture now, we get light on the screen, it's just a solid horizontal line. And then after a few seconds, the set shuts itself down as a protection mechanism. So in this video, I'd like to get to the bottom of what exactly is wrong with the vertical deflection. And if we can figure that out, hopefully this TV will then be fully functional. So fingers are crossed that it's in this part that this TV will work, and I can actually hook up something like a Nintendo to it, and we can see it actually showing something on screen. So the first step in this repair is to try to understand how the vertical section works, and we're going to use the service manual for this set. Huge thanks to one of my viewers who sent this to me. So once I determine in the service manual by looking through the schematics what things are needed for the vertical deflection to work, I can start using my oscilloscope and multimeter to look for the appropriate signals that would cause vertical deflection to fail or work, and then we can go from there and try to formulate a plan of attack for getting this TV working. One thing about these 13-inch TV sets like this is that they all pretty much work in a very similar fashion. These 13-inch ones specifically are extremely cost reduced, and when they're the late models ones like this one, which is from 2003, pretty much everything's been condensed down to a couple chips and then some support components. So while you might be trying to fix a set that has collapsed vertical, it might not be exactly this TV. I think a lot of the techniques that we're using here are still going to apply. And even if you don't have the schematics, you should still be able to kind of look around on the board and figure out what's wrong that causes the vertical to collapse, because really it's all going to be extremely similar to this. Having the service manual with the schematics just makes it a little bit easier, because it shortcuts a little bit of the guessing and reverse engineering you'd have to do on the set if you didn't have these. And it was in the first 2 parts of the series, I think I didn't have the schematic at all, but I was still able to kind of figure out my way around this set to see what was wrong, and I figured out that it was the horizontal output transistor, and that was even before I had the schematics. Now looking at the schematics, we have a few different sections. We have the power supply section, which we pretty much don't need to look at because we know everything is working well. The power supply on this particular set has 2 outputs, 11 volts, and what it says is main supply 97 volts. This is the B+. See, it says VBAT. Yes, the B+, by the way, stands for the battery plus voltage. Anyways, on this set, it's 97 volts, which is pretty much what we get when this thing is plugged into the wall. You don't even have to turn it on for the power supply to run. It's running all the time. And we're also getting this 11 volt rail, which I think when it's not running is something like 10 point whatever volts, something like that. So those two rails are totally fine. I think without this main aux, a lot of the stuff wouldn't work on the set, probably wouldn't even turn on. I wouldn't be surprised if the power supply that goes to the main controller IC, like the microcontroller, is derived from this rail. So if that rail were missing entirely, I think the set would just look like it was totally dead. The next page is the line deflection page. This has to do with the horizontal deflection. This is what we've been working on in all the previous parts. Basically, this all has to work for you to get the high voltage that goes to the CRT, the 24,000 volts that allows the CRT to run. Not to mention, this generates a bunch of these other voltage rails, which are used in other areas of the set. VLOT 8 volts, there's a 42 volt rail, a 27 volt or 25 volt rail, and there's also a 160 volt rail that is generated from the flyback circuit. So essentially, unless the set is actually running, like it's generating high voltage, then you're not even going to have these other rails. But typically, this stuff is not going to go to power up things like the microcontroller, because that's required to kind of start the set. These usually go to the extra support circuits that are required for the set to operate normally when it's generating a picture and has high voltage. Things like audio, vertical deflection is almost certainly going to be powered by one of these rails. The filament voltage on the CRT is also powered by one of these rails. In fact, if we look at the filament voltage, it looks like the VLOT 8 volts, which we know is this one right here, that's generated off the flyback itself. That goes through this transistor, which seems to be turned on, well, based on some feedback, probably from the horizontal scanning. And when this starts to conduct, the VLOT 8 volts makes its way down here through this diode and resistor, and it goes down to this area, and that makes its way to the filament. See how this transistor is connected to this protect line that goes to A2-14, also 10.14, and also we have protect there, protect there. There's also protect up here. I think all of this is really to sense if any of these circuits aren't working properly, the microcontroller is informed of that. It doesn't know exactly what's wrong. It just knows that something is wrong, and it shuts down the entire set. It will turn off the horizontal deflection, which shuts down the flyback transformer, has the effect of removing high voltage from the TV, but also removing these extra rails, which has the effect of turning off the filament. It just basically turns off the entire set. So that is a little bit relevant to what we're looking at here, because I wouldn't be surprised if we go to this page, frame deflection, and when it talks about frame, that is talking about the vertical deflection, the entire frame versus a single line. Horizontal is a line, frame is the vertical. So the vertical drive signal is going to be coming from the jungle IC. That's what takes the video signal, whatever it is, the tuner or composite input, extracts the sync information, extracts the vertical sync information, and sends that to this IC. This is a single IC, the TDA9302H. It takes a vertical drive input and using a power supply input, which looks like it's running off the 25 volts, which is one of those flyback transformer rails, that essentially powers the vertical deflection coil, because you notice here, actually it goes through one side of vertical deflection and the other side of it goes into the output of the power amplifier. So that has the ability to pull the entire scanning beam up or down and, well, allow vertical deflection to actually work properly. So right off the bat, we know there's a few things that are required for the vertical deflection to work. Obviously, the vertical deflection coil itself needs to be good. Well, we already took a look at that in part 3, where I checked it for inductance and it looked good. It also has a good resistance value, and I checked continuity between the connections on the top of the yoke and to the pins on the board. So I was good that the cable and the connector itself were okay. So I'm going to create a list of things that are necessary for this whole circuit to work. And some of these things, like we said, like this one, I've already checked. So physical connection from the coil to the PCB, that is good. Next, we know we're going to need to have 25 volts present at this location, resistor 3763. It needs to be on both sides of it. One side is going to go to the coil itself, and then that makes its way to the output on pin 5. Now, you might be wondering, how does this actually drive this up or down? I think the way these power amplifier works, because this doesn't have two voltage rails going into it, doesn't have a plus and minus rail, is that it's using the plus 25 rail, which happens to be up at the top here in this A section, and probably one of these capacitors to allow it to generate a negative voltage rail internal to the chip. You have to think about the fact that when the output of the coil is just at a steady state, the line is right in the middle. So to pull it down or up, you're going to need a negative rail and a positive rail. Positive rail probably moves it down, and negative rail probably moves it up, or it depends on the polarity of the connection to the coil. We'll reverse that. So you're going to need negative voltage rails to be present. And I wouldn't be surprised if we look at the output on pin F3 or pin 5, and F3 is actually the point you test with. You probably have a waveform that looks like a sawtooth, where it goes straight up, then it goes like this, straight up like this. And we can look on F3 to see what that waveform should look like. Those are actual pictures in the service manual. So I'm just going to write a couple notes here. So we need 25 volts on pin 2, pin 6. It shows 27 volts here. That's the voltage while the set is operating. Remember, that voltage rail is generated by the flyback itself. So when the set's turned off, we're not going to get anything there. I mean, it shows 0.6 volts, but it's essentially 0. Set has to actually be running in deflection mode for us to actually have the 27 volts there. The next thing we need for sure is we need to have that vertical drive signal present. If we have the voltages all present and then we don't have a vertical drive signal, well, we know that's a problem. So that is pin 7, vertical drive on pin 7. And that's test point F2. There's going to be a picture somewhere else in the manual here showing us what that waveform should look like. I'm not sure if it's going to be like a square wave or if it looks like a sawtooth or something like that. We'll have to take a look at that. If we have the correct vertical drive and we have the correct voltages going into these various pins and we have the voltages also present on the deflection coil, that 25 volts, then what we need to do is take a look at the output on F3, which it says when it's operating as 13.2 volts. The 13.2 volts I think is like the average when you hook up a multimeter to it, but if we look at F3, that's going to show us what the waveform itself looks like. So we're going to check the output waveform on pin 5, test point F3 for us to see what that looks like. Now you'll notice down at the bottom we have vert FB. It's probably vertical feedback. I wouldn't be surprised if it kind of takes these outputs and the input and sends this back to the microcontroller or maybe to the jungle IC, just so it makes sure that the vertical deflection is working properly. We know that there's no actual vertical deflection, but if we had vertical deflection and it was working, but the set was still going into shutdown mode, it could be because maybe the feedback was bad or some other thing is bad. Looks like there's a protection circuit up here. It's hooked up to these pins, which of course we know this is the supply to the chip, the 25 volts, and this one is also kind of the supply, but through a diode and with this capacitor and this flyback pin. All these diodes, including I think what this is, a 3.9 volt Zener diode, is probably doing something to create this protect circuit or the protect signal that goes into A1014, which if we trace this, it probably is going to the microcontroller again, so we can validate that well, the vertical deflection is actually happening. Probably it's happening through that pin and also through this pin with this feedback pin. And remember, the reason why, and I mentioned this in part 3, is if vertical deflection doesn't happen, you can very quickly damage the CRT with that ultra bright line. So really the thing just needs to shut down immediately, and it does it after a couple seconds, and then you're supposed to go and fix that problem. Well, while we're testing the set and looking at the various signals that are on here, one of the issues is it's going to keep shutting down. And I have adjusted the screen control on the flyback so it's not dangerous to let the set keep running. So one potential thing we can do is we can actually remove some of these components here, which will disable the protection circuit, at least for the vertical. And that should just help the set stay running longer so we can probe around. Or all you have to do is just reset the power to the entire board, like disconnect the plug, plug it back in, turn it back on, and then you have a couple more seconds to do further testing. I'm just going to add an extra checklist item 1A, check 25 volts at flyback. Well, we did that in part 3. I know that's working. There's a capacitor that's near that part of the circuit and it's good. But we still need to check to make sure that 25 volts is actually making its way to things like the deflection coil and this IC, because if it's not, obviously there's no way this can work. And then if it is, then we have to check to see the vertical drive signal is getting there. And if the vertical drive is getting here and the voltages are getting here, well, then we need to start checking that these components up here are okay around this flyback stuff, because that's going to be necessary for the vertical deflection to actually work. And I suppose worst case is we find all these signals are good, like we have vertical drive coming in and these voltages are all looking good, then maybe the IC itself somehow got damaged. The other thing is, of course, is that vertical drive is not there. If we probe the board, that could be a bad sign because that's going to be coming from the jungle IC. And if the jungle IC has a failed vertical output, we're in trouble because that's not a part I'm really interested in changing out. Now, I've just written down a couple extra things I want to check. So vertical drive output is coming from A426. We should be able to find that. And then the protection is going to A1014. We want to find where that goes. And then the vertical feedback is A427. I have a feeling the A4 is going to be the jungle IC. So that means the feedback goes to the jungle IC and the vertical drive also comes from the jungle IC. And the A10 is going to be the microcontroller. And by the way, A4 or A10 represents a page number, at least in the Philips schematic world. And this is our jungle IC, so M61203FP, made by Mitsubishi. And that's the vertical drive output right there, V out pin 17, and that's going to be going to A3. So that's that page we were just looking at a second ago. And then we have the VRAMP feedback. So this is what's coming back from the other chip. That's that feedback signal. So it has to do with that ramping, just to make sure the deflection is correct or whatever, linearity, I suppose. Pulse output VSync, this probably goes to the microcontroller because it's going to A10. Pretty sure that's the microcontroller. That is probably for on-screen display so it can synchronize the OSD with the screen. So it's not rolling or doing whatever. And then there's a ramp cap, 1 microfarad. probably handles the linearity or something like that. So I'm just going to add a couple extra bits of information here. So the jungle IC, the V out pin is 17. So if we're not seeing vertical drive coming into the IC that creates the deflection, that's this step 4, then I have to go backwards from there and try to make sure that it's actually coming out of the jungle IC. Could easily be coming out of the IC, but there's a bunch of components in the middle, like little resistors and things like that. So we just need to make sure that those are all good. There's a couple of them written on here. That's a little voltage divider, but I wouldn't be surprised if there's like some jumper links and stuff like that. That's usually not represented on here. And certainly A10, this is the microcontroller where that protection stuff is going to be. Let's look at this. I hadn't actually looked at this before. Looks like we have degaussing control, standby control, reset circuit for the set is there. There's the RGB, the OSD output, which we could take a look at if the set ever works properly to see if this is 5-volt TTL or analog. We can see some of the GPIO lines there. It looks like audio standby. Okay, here, protect. So it looks like if this line is ever pulled low, I think this thing in the box is while the set is off. But while it's running, it should be 4.8 volts. If it ever gets pulled down to ground by one of those circuits we saw over the set, then the microcontroller shuts down the entire affair. This is totally besides the fact because not something we ever have to worry about, but there's the I2C connection that goes to other things on the set. Looks like there's the EEPROM. This is using I2C as well. It is connected all to the same bus as everything else. It looks like there's actually a service mode switch, SDAM. We have to look see what that means exactly. Not sure. All right, well, I think I figured out everything I needed to figure out from this, and now it's time to start probing around on the TV to figure out exactly what's causing this not to work. All right, let's get this show on the road. So first off, I'm gonna switch this over to DC, and we're gonna start checking some voltages. I have the set powered up, and it's not turned on, but it is powered up. So first thing we're gonna look at is B+. There we go, it's looking good as expected. And if we check our voltages now while the set's not running on our vertical deflection coil, yeah, we're not going to see anything at all. And you know what I'm going to do is I'm going to unplug the CRT here. We don't need to have that plugged in because we don't need any kind of line drawing on the screen. It's not necessary for this testing we're doing. Now let's turn the power back on. Just make sure we have our B+ there. We do, looks good. Okay, so what I'm going to do is I'm going to turn this on and I'm going to check to make sure that we have our 25 volts on this connector, which happens to be the one that goes to the deflection yoke. Okay, we're getting 2 volts there and no volt there, and it turned out, the set turned off. So we're not even getting our 25 volts there. The set was absolutely running though. I heard the high voltage and it sounded all normal. Let's check the 25 volt rail, and I'm going to check it on the capacitor here that's coming right off the diode and the flyback. All right, decided to switch to clip probes, just a little bit easier to see. Okay, so I'm on the positive side of 2723. Yeah. Okay, 27 volts, so that looks good. We're getting the correct voltage rail at the cap, but why wasn't I getting it at the actual deflection coil itself? Now, perhaps what I should do is we should look at this capacitor here, 2750. So this is the supply voltage that goes to the power amplifier for vertical deflection. Let's check for 25 volts there. Same rail, it's just on 2 different sides of the schematic. Now, if we look at the board, that actual IC is right here. That means 2750 is probably going to be right nearby. Okay, I'm pretty sure I'm clipped onto the correct spot. Let's turn this on. No, maybe I'm connected to the ground side. Yes, I was. Okay, let's try that again. There's 27 volts. So 27 volts is getting to the IC itself. According to my little paper, I should see 25 volts on pin 2 and pin 6 while the set is operating. So I'm clipped onto pin 2 of the vertical deflection IC. And there it is, 27 volts. Okay, so that means the chip itself is getting powered up. So not having checked any of the drive signatures yet, we're just looking for the voltages still. Looks like the vertical deflection coil is missing the 25 volts. So I need to see if this resistor here, 1K5, actually has 25 volts on both sides of it. It's quite possible that there's like some kind of a short, maybe over here in this section or on the chip itself, that's causing that thing to bleed off all the voltage. So on one side we'll see 25 volts, on the other side we'll see like 2 volts or whatever we saw. So we're looking for 3763. All right, so 3763 is a big power resistor, it looks like. Comes from up there on that side. So I'm going to clip onto the top side. The bottom side is the side that looks like it makes its way to the deflection coil. So yeah, top side should be 27 volts. And if it's dropping it across that resistor, then we have some kind of a short somewhere. Okay, so I'm turning on the set. B+ is there. Looks like we have a little bit of voltage. There we go, 2.7 volts. Okay, so I think this is the side that faces the deflection coil now, the vertical side. Oh, 27 volts. Ah, Well, that's not good. Now you know what that's interesting is this 25 volts. It doesn't say anywhere on the schematics what any of these voltages should be. So we're seeing 25 volts on the right side of that resistor, but on the left side we're seeing like 2 point something volts. Now if we just look at what's happening here, it looks like there's a voltage divider there, but the problem is that's a 33K, so that shouldn't really pull down a 1.5K resistor. And then this is a voltage divider. There's a 2.2 and a 1.5, but we have a capacitor in between, so that should block the DC. So that's not really a valid voltage divider. And if we go over there, similar situation, that's a cap that goes to ground through that stuff. And we think about this 25 volts goes to the deflection coil. So that has a few, whatever ohms of resistance, 10 ohms or something like that. But it's not directly connected to ground either on the other side because there's this capacitor and this is ground, but that's also through a capacitor, and there's the IC itself. I suppose one thing we could do is we could just unplug the deflection coil and then look at the pin 2 or look at the other side of this resistor and see if the 25 volts is now visible. So that'll tell us if that voltage drop is happening because the coil's plugged in and something on the other side of the coil, which of course is the IC itself and those components, is causing that voltage drop. Okay, so we're back on the top side of that resistor. I'm going to turn the set on. B plus is visible or there. Let's turn on the set. We're getting like 7 volts. And back on the other side of the resistor, this should be 27 volts. Yep, 27 volts. Now looking at the schematic again, so we're getting like 7 volts here without the coil plugged in. We do have these resistors that make their way to the IC, but this stuff over here, I don't really see us having that voltage drop that we're seeing. Maybe we should take a look at pin 5, the output of this chip. It says it should be 13.2 volts while the set is running, and that's on a multimeter, not with a scope. Okay, I'm clipped onto pin 5 of the vertical deflection IC. Turn on the set. We're getting like 1.9 volts there only. And again, let's connect to that resistor. So 27 volts there. We just write that down on this paper. And the other side of the resistor, 7.6 volts. And I have the vertical deflection coil reconnected. We turn on the set now. We're getting like 2.7 volts. Right, so this is what we're seeing. 27 volts on that side of that resistor, 1.5K, 7.6 with the coil disconnected, 2.7 with the coil connected, which implies to me that the voltage is being eaten up by the IC itself, and I don't think it's this stuff over here. One thing I should probably do is just double check that this resistor is measuring 1.5K, the power resistor. It's a metal film resistor. Maybe somehow it got damaged and it's a higher resistance. Well, I'm measuring this in circuit. We're getting about 1.5K. So I think that's fine. No issues. Yeah, it's slightly fluctuating, but normal. Okay, so the resistor is not the problem. Problem is somewhere else. It kind of annoys me that they don't have any of the voltages that this stuff should be over on this section. So it's quite possible that everything we're seeing here is completely normal, and really I should probably be focusing on the vertical drive going into this chip. We know this chip has voltage, so theoretically it should be outputting some kind of a drive signature. First things first, let's check F2. This is the input on pin 7. That's the vertical drive signature that we're getting from the jungle IC. This is F2. That is the waveform we're going to be looking for. So it's a sawtooth, and 500 millivolts per division is what we're looking for. Now it's going to be at 60 hertz, so we need to make sure the oscilloscope is set appropriately. So I don't know, have it at 5 milliseconds per division, and we'll see what this looks like. Okay, didn't really say on that diagram that we needed to have this AC coupled, but I can do that. Let's try that again. So there's a waveform, 60 hertz. Good, we're getting a drive signature from the jungle IC, and this TV just turned off. That's excellent, because that means that this jungle IC, the one that I wasn't going to change, is definitely okay. It seems that the problem might potentially lie in this IC here, this power amplifier chip. So F2, that was what we were just looking at. That's the waveform, look good. Let's look at this F1 waveform, which is pin 1, and it should look very similar to the one we were just looking at. So I recycled the power on the set since it went into protection mode. So if we turn this on, yeah, okay, looks good. And that's what you would expect to see. So that tells us that the input signals going into this power amplifier are looking good. Let's check the output signal. It should be 13.2 volts, and we should be seeing some kind of waveform. I don't have the coil connected right now. All right, here we go, 3, 2, 1. And pretty much nothing. I guess what I should do is connect up the deflection yoke. Okay, I've recycled the power on the set. There we go. Nope. Big old nothing. there is nothing coming out of that IC, even though we have something going into it. Now we happen to know that the supply signal on pin 2 looks good. This pin 6 also looked good, but I'm really starting to think that this vertical deflection IC is bad and it's a problem. And I guess this whole 27 volt thing over here was not real. And because it didn't have any voltages printed on here, and I'm not familiar with how these circuits work really, I wasn't sure what these voltages should be, but I guess what we're seeing there is actually totally fine. So I guess that means I need to pull this out and I need to look through my scrap boards to see if any other TVs use a similar IC to this. And let's hope that they do, otherwise I'm gonna have to order something. While I wait for this to warm up, I'm looking for spare parts. Obviously, this board does not have an appropriate spare part. It has two 3-pin packages that obviously are handling the vertical, so not that one. And then we have this board. This is the one I stole the horizontal output transistor off of. It has a package that has the right number of pins at least. So I guess I'll need to remove this one and we can take a look to see if it's the same and is compatible. Okay, well, removing this part is annoying. I have it desoldered, but the screw is on the other side of the tuner. So I need to remove the tuner just to get to that screw. On this parts board, it's actually a bit better because the screw is, instead of being on this side where the tuner is, it's on this side. So this is that IC from the parts board, LA78041. I don't know if that's going to be compatible. Wow, this is very annoying. So I have the tuner kind of loose, but the problem is besides soldering on the shielding, they twisted a couple of the pins. So I've untwisted them and I'm just trying to clear them out, but they are hanging on for dear life. Okay, I think I got it. I think, yep, there we go. Wow, that was annoying to get off, but it's off. And would you look at this? Does that not look like a burn mark or something? Right there, coming from that little power amplifier for the vertical. Oh yes, that chip is blown up. It's got a big crack in it. Hopefully that's coming across in the camera and it's in focus, but it's absolutely, this chip was destroyed. Now sadly, if this were easier to see, I would have been able to see that, but the problem is the tuner there and this cap there really prevented a good look at this chip. But now that it's out of the board, without a doubt, that's a blown up part. And while this other component that I took off the other TV has the same footprint, exactly the same footprint, I'm gonna have to go look at the data sheets on these to see which one's gonna work for us. All right, here's the data sheet for that chip I pulled off that spare parts, LA78041, TV CRT display vertical output IC with bus control support. If we take a look at the application circuit example, I think this is all the same. So VCC 24 volts goes into pin 2, there's a diode, it goes into pin 6. If we take a look at the actual schematic on here, so pin 2, that's the 25 volts, the diode, that goes into pin 6, and then we have that capacitor for the flyback into pin 3, which again totally matches. There's that diode with the band facing the capacitor. The band is facing the capacitor, goes into pin 6, then it goes through the capacitor into pin 3. So band goes into pin 6, and then it goes through the capacitor into pin 3. Pin 4 is ground. Pin 4 is ground, the output is pin 5. There's the output right there, there's the deflection yoke, so it comes out of pin 5. So the input, oh, this might be a bit different. Take a look at this. So it goes into pin 1, and pin 7 is just hooked up to 5 volts. Although maybe that's just this exact example. And actually, if we take a look at the data sheet of the one I took out of this set, it also has the input going into pin 1. Pin 7 just shows it as floating. And they just decided to do it a little bit differently on the Philips TV. But I think that should be still fully compatible because it's got the same amp there with the two inputs. The negative input is on pin 1, which totally matches what we see in this schematic for the TV. So negative inputs on pin 1, positive inputs on pin 7. And that completely matches exactly here. So I think this is a drop-in replacement. I don't know why the part number is completely different, but I assume that was just Philips making these different TDA part numbers when the reality is this stuff is somewhat interchangeable. I also laughed at the original part and the one that replacement one I have has this thermal protection, but it didn't protect it from getting damaged, did it? Just so you can see close up with this camera, the carnage of this IC, you can see it's blistered out there. Yep, and that's what that little burn mark on the heatsink was from, clearly. The rest of the package seems fine. There wasn't a whole lot of thermal grease on there, so I'll clean that off and add some new thermal grease. And then here's our part that I'm going to be installing on here, the LA78041. And the good thing about using these parts off of junk TVs like I'm doing is that these aren't fake. These are real parts. And that's always one of the danger if you order one of these nowadays is you might get a fake part and then that'll just ruin your day because you're going to be chasing your tail trying to figure out what's wrong. The new vertical output driver has been soldered into the board. I have the oscilloscope clipped onto the output pin. That is pin 5, I recall. Yes, 1, 2, 3, 4, 5. And the tuner has also been soldered in because I'm not sure the TV will work without it. I did not reconnect the shield just in case I have to remove it again. Getting those pins desoldered is easy, but the shield part is the difficult thing. What we're going to do here is I'm going to turn on the power, turn on the set, and we're going to look at the output. We should see vertical deflection going negative and positive. The yellow line is currently at ground. Deflection yoke is connected to the board, so we should have proper deflection if that chip doesn't cremate itself as soon as we turn on the set. But all the voltages look correct, so I don't see why it should cremate itself. Maybe people running it without the deflection yoke connected before damaged it because the voltages were too high or the load was incorrect or something like that. I'm not sure. Okay, here we go. B plus is there. 3, 2, 1. Okay, what's happening there? I did not see anything not coming out of this chip whatsoever. So again, let's check some voltages here. Pin 2 should be 25 volts. So I know the set actually starts. So let's try turning this on. What's going on here? The set's not turning on. Well, that's interesting that I have caused a different fault here and the TV won't even turn on now. We're going to check some voltages. So first of all, B+. So when we turn on the set, uh-oh, no B+. Huh. I'm not sure what's happening. How about the 11 volt rail? No. Okay, do I have the ground leads connected? Just double check everything here. I think I did not have the ground lead connected properly. Yes, there's B+. Okay, my bad, my bad. Let's check the 11 volt rail. There it is, 10.4 or whatever. That's fine. All right, this should be the 25 volt rail when the set's running. Okay, yeah, something's weird going on now. I'm going to spend a moment and look closely at the soldering I did on this tuner and on the vertical deflection IC just to make sure I didn't cause any shorts. Now the question is, what's going on with the set here? Is the horizontal output transistor, has it failed? Or is the drive signature not there? Because I wasn't really getting any high voltage. The set just didn't seem to be doing anything. It sort of seemed like it was just dead. Now I did touch the heat sinks that are back here and both of them were cool. So the horizontal output transistor wasn't burning hot or anything like that. And we definitely had B+, we had the 11 volts, so the set should have tried to run. Probably what we should do is take a look at the drive signature on the horizontal drive transistor. So I'm on the side of the transformer that's not on the high voltage side, I'm on the low voltage side because I'm only using a 10x probe here. All right, so we're getting our 9 volts, which is correct. That's what we should get when power is supplied. There's just no drive signature at all. What's funny is when I push the power button, I see this thing move a little bit. Like there it is up at 10 volts and I push it. See, it went down a little bit and then didn't actually start oscillating. I feel that I have to have caused this issue by trying to take the tuner out. Like, did I break another component, like one of these little surface mount components over here that's somehow causing this problem? Let me check the voltage that's going to the tuner. It looks like it's pin 7. 2, 3, 4, 5, 6, 7. So we turn on the set. It's weird, it's like 0.2 volts, which might be okay. Let's try turning it on. I don't get 5 volts there though. Okay, and here's another pin, pin 9 on the tuner. Looks like when this set is just powered up but not turned on, this should have voltage on it, and it doesn't. So why is the question? Why do we have no voltage there? I know you can't really see it too well, but it's this pin 9 and it comes from this VT, whatever that is. It should be like 31, 32 volts all the time. Oh, actually VT is one of the rails that comes off the flyback transformer. It's this 42 volts here. So clearly this VT line here on the set never is gonna have 32 volts or 31 volts while the set is off. That's impossible. It's only gonna have that while the set is operating. That's ridiculous. So I'm at a bit of a loss. I think I need to just remove these components from the board and then see if the TV at least goes back to the way it was. I mean, it's possible this vertical deflection IC I installed is bad. Maybe it's shorted also. I took it out of a set that I couldn't test. It was a junk set. So that could be our problem. I'm just going to spend a moment to remove this stuff, I guess. So I went ahead and removed the tuner. Let's just see if that makes any difference. I'm clipped onto this so we can see horizontal drive, if there is any. Okay, there's the voltage. We're at like 10 volts or whatever. Oh, the TV's running. Wait, really? Let's try that again. Yeah, so it's running without the tuner installed. I assume it's going to shut down. I bet you there's some protection that watches for the tuner. Let's give this a try one more time. Let's see if it stays running for a little while. Okay, it's running without shutting down. Okay, why? Is it because I didn't have those ground lugs connected? It can't possibly be that, right? Well, that was kind of anticlimactic. What I did is I clipped onto pin 5, that's the output of the vertical deflection. Let's see if we have proper deflection. I've changed the time base to 5 milliseconds and it's 5 volts per division. Okay, let's see what happens. Yeah, there's our vertical deflection right there. It's freaking working now, I think. I mean, we don't know until we actually look at the raster on the screen to see if it's actually having full deflection or what, but the set kind of works now. So that's really confusing to me. Why having this connected kept the set from even turning on? All right, with the power unplugged, I'm gonna plug the neck board into the CRT so we can see if we actually have proper deflection. All right, everyone, are we ready to see if this TV actually can work or not? So I'm gonna plug the power in there, move that out of the way. Let's turn on the power switch. TV should not auto start. So it's off right now. I have to carefully reach around here and push the power button. All right, wait, so I turned off the power because we didn't see anything and we saw what looked like full deflection. I forgot I had the screen voltage turned down. So we need to turn this back on. And it's so weird because I don't have the speaker hooked up, and because the set already is charged with high voltage, when I turn it on, you don't hear that static charge sound as it powers up and charges up the CRT. It's already charged right now. This set design does not have a bleed resistor, so this is currently just at full voltage. So when you turn it on, there's just no sound to be heard. So I'm going to turn it on. I think it's on, and I'm going to grab a little screwdriver so I can adjust the screen. Oh my goodness. There it is. There is the C. Oh boy, it is operating. This TV finally works. Trying to peel this off. I am completely shocked. I mean, not really. Kind of made sense, but there it is. There it freaking is. Wow. Let's turn that off. I'm going to plug in the test pattern generator. I kind of assume what we were looking at there was the video input. So whoever last used this was using on video input. I'm just going to quickly touch the heat sinks. Vertical deflection heatsink, totally cold. Horizontal deflection, totally cold as well. Awesome. So it was running there for, I don't know, like 10 seconds or so. Let's turn this back on. And the test pattern generator is connected to the video input. Now I got to reach around carefully over all this dangerous stuff. There it goes, I think. Okay, so obviously that is not video input. Oh, that looks like garbage. Oh, there we go. It's like super blown out and horrible looking. Interesting. All right, well, there's some interference patterns and it looks kind of terrible, actually. Just overall looks bad. Like the blue is just missing entirely, but the blue is there. Interesting. And this gives you an idea of how terrible it looks as well. So the lines that are running horizontally are pretty bright, but the vertical lines are quite dim. So all does not seem well with this television, actually, even though it's clearly running now. I'm going to fiddle with the screen control a little bit. So that's really weird. So the screen control currently is set all the way to the bare minimum right now, and we still have visible lines. Why? And focus control works as expected. Huh. Why having the screen all the way to minimum still results in these lines? That's weird. And they're looking at the color bars. That's with the screen control set to the bare minimum, and there's somehow still a picture. That's weird to me. It shouldn't really be visible. And when I switch to here, it says like AV, and it's all bleedy and horrible. Everything just looks really, frankly, terrible here. Also, one thing I'm noticing is now that we have an image on screen, that scratch is pretty deep. Definitely catches my fingernail quite a bit there. So that's something I'll have to try to address with a polishing kit, which I did buy. So I'd really like to poke around in the service mode on this set, and there's actually a point you can ground on the board. My little stick is pointing right to it. You have to ground that when you turn on the set, and it puts it into service mode. The service manual talks about it. There's also a sequence you can type in from the remote to do it, but I don't have a remote programmed right now for the TV. So I'm just gonna try this with that ground point and see if we can fiddle with some of the settings to fix some of the terribleness of the way the set looks right now. I have the set reassembled, and I'm just gonna turn it on first just to make sure that it still works, that it hasn't broken, before I try the service mode. All right, what's sort of strange is it's definitely running. There's high voltage. I have the input connected, but we're not seeing anything. So I'm gonna try to turn up the screen a little bit because I think I had it at minimum. Oh, well, that's better. It's still all messed up. That's the screen turned all the way down, and it looks, well, completely washed out and terrible. Part of me wonders if they turn the cathode drive up to maximum in the service menu, and that's what's going on here. I'm not actually sure what's really happening. If we push the power button, it turns off normally, and let's turn it back on. Yeah, this is horrible looking. It's all bleeding and terrible. All right, so the board is sort of out of the TV. That way I can reach that service mode point with this and also push the power button at the same time. So I'm touching that ground point, and I just turned on the TV. There we go, we're in service mode. Wow, it looks horrible. You know, I don't really understand what's going on. The screen control is all the way at minimum, and it's so blown out right now. It should just be totally dark. There's got to be a fault right now that's causing this. And it says it wants us to go to the DR menu. Okay, so we're turning the drive down. Okay, yeah, there's clearly something wrong here with the set. There's no way it should look like this. I am able to control the drives, but it's just it's so bright and blown out. It doesn't really make sense. Now I'm sort of thinking about what might be happening here. The screen control doesn't seem to be working properly, meaning I turn it all the way down. The screen should just be totally dark. It shouldn't have this super bright picture like it does right now. I think it was in part 1 where I thought this flyback was bad and I actually put the other flyback in place. And to swap the flyback over, you have to open up this connector here. And I'm wondering if I somehow messed that up when I did that. Because of these two wires, one of them is screen and one of them is focus. Well, the focus control definitely works. When I turn it, it gets blurry. The screen control works. Like I turn it, it seems to have an effect. But clearly something's wrong here. Okay, no, a little bit of reading, and this thinner of the two wires that goes to this is the screen voltage. This is focus that's going into the actual body of the connector itself, because it goes to this shrouded pin, since this is very high voltage. This is still high voltage, it's like 400, 500 volts, so it's not like it's nothing. But I think this is like a couple thousand volts, which is why it's a thicker wire and it's going into the connector. The screen voltage goes to there, and to pin 8, and that totally matches exactly what it says on the schematics for this little board here. I think what I need to do is get this hooked back up again, and we need to get the oscilloscope on the cathode drives going to the CRT. We need to see how hard it's actually driving them, because of the blooming that I'm seeing makes me feel that it's being overdriven. Although thinking about this, I think what I need to do is take a look at the screen voltage that's coming through, and we'll just need to look at what that is. According to what's on there on the screen, I know you can't see that, it should be about 480 volts. So I'm going to clip onto that point, and I'm doing it in a way where I don't have to touch anything, and we're looking at DC volts, and I'm going to unplug the video source so we just have a black screen. Turn on the TV. 97 volts. I mean, that doesn't seem very high. Yeah, so I turned up a potentiometer on the flyback, and now we're at like 271. So screen control's working. So it feels like it's just driving the cathode super hard, and I guess if you do it hard enough, even 97 volts will result in a bright image like what we were seeing. So I don't think this is a problem with the flyback and the screen. I think this is a problem with the cathode drive. Okay, so I just clipped onto 3305. It's a resistor. And this is going to which of the guns? It's going to the red gun. According to the schematic, this should be at 167 volts when the set is operating. When it's not operating, it's just powered up, we should see B plus there. So yep, there's B plus. Now let's turn this on. Okay, 173 volts. Let's connect the test pattern here. Okay, it's down to 106 volts. And of course, yep, I have like an image on the CRT. Okay, so this is where I'm a bit confused. 104 volts, that's for the cathode drive. That's nowhere near ground. And if I unplug the connector, that should go up because we're gonna have a black screen. Yeah, 170 volts. And we do actually have a black screen right now. But then we know that the screen voltage coming from the flyback is like 97 volts. And generally the higher the screen voltage, the more the electrons are flying towards the front of the CRT. So lower voltage, dark screen, higher voltage, more light on the front of the screen. I forgot to explain this in the video, but the cathode relationship is the opposite. So the closer cathode is to ground or 0 volts, the brighter the spot you're going to have on the CRT, or the higher the emissions. So 100 volts is much, much brighter than say 170 volts, and it does interact with the screen, which remember is opposite. Higher voltage equals higher brightness, lower voltage, lower brightness. So screen voltage is super low right now, and yet, well, we have this super bright image. Back on the cathode drives, when I look at the numbers that are printed on the schematic, it's saying that while the set is running and you have an image of some kind, I guess, it should be 152 volts to 173 volts. This is on the different red, green, and blues. All the kind of the stuff that we were already seeing. So here we are, I'm clipped onto pin 3, and there's the B plus because the set's off. We turn this on. Now we have a black screen, 175 volts. We plug in an image of some kind with a test pattern generator, and it goes down to 99, which is, it seems like that's too much. And maybe that's why the image is all blown out. Like this is just scaled wrong. And here's something that's really wild. See on there, it says AV. So that looks normal. The text that we see on there is clear. This is the on-screen displays. And I actually had to turn the screen way up to even see that. When I turn the screen way down, the screen control on the flyback, that pretty much disappears entirely. Let me demonstrate that. Okay, so see, there we go, it's gone. So it feels like the on-screen displays have a normal brightness. And if I push the up and down buttons, there's like channel 2, we got a blue screen that looks fine, AV, the volume control stuff. It's that when I plug in a video signal, everything is incredibly blown out. But the on-screen displays look fine. In fact, let's turn the set off, and I'm going to go into service mode. There is service mode. Not even looking horrible. What I'm going to do is I'm going to plug in the video cable that has a 0% field, so it should be just a black screen. Let's look how that looks. Okay, yeah. Just went into interlaced mode, but otherwise it seems fine. So there's definitely a problem with the video processing that results in anything being driven through the cathodes to be way, way too hot. Obviously the on-screen displays, they're looking fine, no issues whatsoever. But clearly something is wrong whenever I input a video signal, it's just way, way too bright. And again, here's that example. I'm gonna turn the screen down all the way on the flyback, and I think the OSDs, yeah, pretty much disappears, as one would expect. And we turn it back up, it gets very bright, and you can start to see the gray background. This is all exactly how it should be behaving. But as soon as I feed this any kind of video signal, the output of the video processor is super incredibly blown out. And that's a problem. And I don't think it's a problem with the CRT or the neck board. I was kind of looking in the wrong area because now I see the on-screen displays working fine. Clearly it's a video processing problem of some kind, which unfortunately is that jungle IC again. It's amazing the amount of faults this TV has. It's absolutely amazing. Is what if this video problem is caused specifically by the fact that the tuner is missing? Is that possible? Maybe the tuner being in place causes, I don't know, one of the voltage rails to be lower and not overdrive so hard or something like that. Not totally sure. So just in case the tuner is causing a problem, I went into my pile of tuners and I found this one, and it definitely is a compatible match. Well, at least it goes on the board and the TV turns on now. I'm not sure what was wrong with the tuner that I took off the board, put back on, and it didn't work. I obviously didn't try to reinstall it, but I'm thinking that maybe when this was installed on the board, it was crashing the I2C bus, causing some kind of a bus conflict. And I think when that happens, the TV won't turn on properly because the microcontroller's running and you try to turn on the TV and it tries to talk to the jungle chip over I2C and it isn't able to communicate to it, so that means the set never starts up. That's the only thing I'm really thinking, because all the voltage rails when we had this tuner installed were looking good, but the TV was not turning on. So with this tuner in the board, I haven't actually tested it to make sure that it can receive channels, but the TV is still working with it installed in the board. And what I want to do is I want to hook up an RF source to the TV and see if the video signal coming in from the tuner looks okay, or if it's all blown out as well, just like the composite input on the front jack. There are separate jacks. I think there's separate inputs into the jungle IC. So if the composite video one is, say, damaged or there's something wrong with that circuit, this should help us identify where the problem lies. I have broken out a VCR and I have a tape in here and I have it hooked up to my RetroTink just because I want to make sure the VCR is working. And sure enough, there is the video signal. It's just a random tape of some scenery footage that I recorded on one of my other VCRs. I do have this Harmony remote programmed to control the TV. Okay, we have audio. That's funny. Haven't actually heard that work. Yeah, I guess that looks fine. It's dark, but I must have the screen turned down. One way I can tell is I'm gonna short out that ground pad so we get to service mode. So I touch the little point there, turn on the TV. All right, there we go. Interesting is it's a lot brighter now. I think what had happened is I had gone into the menu on the TV and turned the brightness and the contrast all the way to the bare minimum. And when you go into service mode on this TV, it seems to reset things. Because now the picture's a lot brighter and the on-screen display seems to work fine. Channel, AV, channel 3. Well, we know that the tuner works, the one I installed on the board at least. All right, so one thing is when I'm on the AV input with no signal input, I do see the background, and I think that should not be there. So I'm gonna adjust the screen, just turn that down so we don't see the raster anymore, like that. And yeah, I mean, the image looks freaking great. I don't think we're having any issues with it being blown out or anything like that. And boy, does it look better than the LCD screen there through the video capture. This is just so vibrant and bright. And as you can hear, the sound is working. So that's fine. So this is telling us that the RF input is fine. And what happens with the tuner is the RF signal goes to the tuner and then an intermediate frequency RF signal is output from the tuner and it goes into the main jungle IC, and then that converts that, the VIF, the video IF, and the SIF, sound IF, into audio and video. The SIF is the sound IF that turns into the audio signal we're hearing, which is obviously working, and the VIF is converted into composite video, which is what we're looking at. And I mean, it's VHS. It looks VHS-y, which is not great, but you know, it is working. And there's our service menu, and well, it looks it looks absolutely perfect. And our next test is, here I'll just turn off the TV, is let's plug in the composite video from the VCR and the RF at the same time so we can switch between them and compare. Okay, the TV is plugged back in. Let's power this back up. I'll go to service mode while we're at it. Fine, we're still on RF though. Yes. So there's the video input. You know, it doesn't look nearly as blown out as the composite video from my test pattern generator, which is a Tektronix test pattern generator. It just looks kind of washed out, but I don't see a whole lot of the bleeding in the on-screen graphics as I did with the test pattern generator. Yeah, well, that looks interesting and bad. Okay, well, one way we can tell is I can just turn the screen control all the way down, and we need to see if we still have an image. Okay, so there we go. I turned the screen all the way to the bare minimum there. And now let's switch back to RF. Yep, so this is the RF. There's sound. There's a tiny bit of image there. but obviously we're still way overdriving the cathodes on the composite video compared to RF. So it seems like RF is working perfectly, absolutely perfectly. Let's turn this back up. Okay. And now I put it back on channel 3. We'll start the tape. There we go. And I haven't even gone in and adjusted the brightness, contrast, or color, or any of those settings that are in the menu. Oddly enough, even though I can kind of control the TV with the remote, like I can type channel numbers and things like that, what I cannot do is go into the menu. And no matter what I do, like programming the remote, and I have another thing for my phone, I can't get the menu stuff working at all. Wow, the image is just perfect. It's super bright. But look at that. Horrible. Absolutely horrible. Yeah, it's totally overdriving the CRT. So I can get into the menu on the TV for like picture and stuff by double pushing, I think, the volume up down. That brings up this. But I cannot move around with the remote still. All right, so there's brightness, color sort of in the middle. Picture, which is the contrast, or brightness, or white level, I'm sorry, is also in the middle. So it looks like going to the service menu, just sort of reset everything. Contrast plus off, turn that down. It doesn't really get that much dimmer, to be honest. It's funny. What else is on here? Smart lock, it's probably sort of like kids thing. Setup, language, cable, auto program. We're still in service mode. So the options we have available in here, I think there's an options menu. SF, AV on and off. I guess it turns off the AV input. ST is probably stereo sound. SF, what does SF mean? Then we have the drive controls, and with this particular Jungle IC, all you can do is adjust the red and the green drive, or red and the blue drive. There's no green drive control. I looked at the datasheet for the Jungle IC, and that coincides exactly with what it says in there. You just cannot adjust the green. That's fixed level. So you have to adjust the relationship between the other two drives. Then we have cutoff control. So we do have red, green, and blue cutoff control for each of these. I assume this is some default values, I guess, or maybe this is what was in here before. I don't know. These don't look messed with because the picture looks perfect. We haven't looked at the test pattern because it's all blown out when I hook it up, but that looks fine. Then you have VCO, voltage controlled oscillators, has to do for the tuner. Vertical size, vertical shift, so we can shrink the picture, we can move it up and down, and then there's a horizontal phase, so you can move it side to side. There is no way to control the width in the menu, that is. And there's a chroma trap thing here. I don't know, 2 is the value that it's on. And that's it. That's all it has in here. There is a stored error code too, I think in the service manual. It lets you look up what that is, but it's not really relevant. And the only other thing in the menu is CC, or closed captioning, which are subtitles. That's it. This menu is extremely simplistic, but wow, obviously the TV's working. It's working fine through RF at least. It's completely freaking running. What we're seeing right now tells us that this TV has the capability of operating properly. And now I just have to figure out why the video input looks so bad. And the fact that the composite input on the front of the TV looks bad, but the RF looks good, kind of leads us to believe that there's a problem on the front end section for the composite video. Maybe it's not being terminated. It should be 75 ohm terminated on the set. Maybe that's broken or missing, and that's causing us to be so blown out. So I think that's the next thing we need to do, is investigate the termination or the entire front end buffer circuit on the composite video. Awesome. I'm so excited though that this TV finally, obviously, is freaking working. Here's the cinch or RCA jack for the composite video input. There's a little spark gap. We have a 100 picofarad capacitor. There's our 75 ohm terminator. That's the resistor to ground that terminates the entire signal. Then we have 100 ohms, and then it goes off to, I guess, the Jungle IC. This is all pretty typical for the input side on composite video. You always need to have the 75 ohm termination to ground on the set. And on the supply side, that's on the thing generating the video signal, you're going to have a 75 ohm resistor in series. And basically those two together create a voltage divider, which brings the level of the signal down. And if the 75 ohm termination resistor here to ground is broken or missing, you're not going to get that voltage divider, and that means the entire video signal is just going to be too hot. The voltage is going to be too high on it. So this red clip is connected to the audio video input, and there's the continuity beep. And I started tracing out the way the signal goes. It just kind of goes over here to a jumper link there, and there's a trace that makes its way down here over here to this jumper link. So you hear the beeping, and you can see that this is in proximity to the Jungle IC. So this stuff here is what brings the video signal to the Jungle chip. Well, I've identified the problem, and it's not even obvious. So these are tiny surface mount parts, and I'm not sure they're going to be clear enough on the video for you to see them. But this part right here is 3101. That's the 75 ohm resistor to ground. It's labeled as 750. That's the marking on the surface mount resistor. And then this one over here, that's the 100 ohm resistor that's in series with the video signal. And I think this side of it probably makes its way over to the jungle chip. We'll take a look at this. I have the multimeter in resistance mode, and remember, it's clipped onto where the video input is. If we take a look at the jumper link, there we are, 0.46 ohms, so that looks correct. If we take a look at the side of the 75 ohm resistor that is facing the video signal itself, now not the grounded side, but the video signal side, we are at 0.4 ohms, so that has good continuity, and this is the one that's labeled 750. Let's check the other side of that resistor. 26K, and earlier it was 35K. So I think this resistor is broken. It should be reading 75. And if we look at this 100 ohm resistor over here, the one that's in series, this is the side that faces the RCA jack itself, 0.4, looks good. And if we look at the other side of it, that faces the jungle IC, 100 ohms. So that looks perfect. But our 75 ohm resistor, clearly dead. And that's our problem right there. 26K, not 75 ohms. Our voltage divider is broken, and that's going to create a video signal that is way, way too hot. Now, hopefully I can go to my parts board and find a 75 ohm resistor for the video input on this and steal it, because I don't have a surface mount 75 ohm resistor handy. But surely there's going to be one on this board I can just take off. You know what? This one uses a non-surface mount component for 75 ohms. That's fine. I can actually just steal this and put it on the board somewhere else, and that'll work. Okay, first things first, I'm going to take this 75 ohm resistor that's bad off the board entirely. Let's just turn up the temperature a little bit on the soldering iron. Okay, so there is the video signal on the 100 ohm resistor. Here it is on the 75 ohm resistor, and here is the side on that faces ground. 75 ohms, as it should be. And there's the 100 ohm resistor on one side, and on the other side, 100 ohms. I can't believe that surface mount resistor went bad. The board is just covered in surface mount resistors, so that was the one that decided to fail. And unfortunately, I don't have it to measure. I mean, we measured it on board, but I don't have it to measure off board because it flew away when I flicked it off. Okay, I just put a little bit of Kapton tape under the resistor just to keep it from ever touching the pads that are nearby. Let's test this out, I guess. Are we ready to see what happens? I'm going to turn on the power supply. Okay, and let's turn on the set. Okay, we're going to get blue screen because I think we're on channel 3. It's interesting how it looks really dim. Oh, you know what? I think when you go into service mode, it actually, everything you have set in here is actually completely reset. Let's see about that. Oh yeah, look, I have picture all the way at minimum. Oh, that's why when we were in service mode and I adjusted the picture all the way down, it didn't really do anything. Ah, it disables all that stuff. Got it. Well, let's just set this to reasonable middle levels. Contrast plus off. Right, okay. Oops, I ended up turning that back on. Okay, so we are on channel 3 right now, which I don't have the RF hooked up. That's why we're not getting anything. No problem. AV. I mean, that still looks a little overly bright, doesn't it? But I suppose a good test is, let me turn down the screen control and see if this all disappears. Fortunately, the way the board is set up, that's all the way back here now. Yes, it works now. Yes, it freaking works. That is awesome. I mean, that looks good now. That looks perfect now. That really looks good. Okay, fiddling around with the controls a little bit. That looks excellent. Picture's looking freaking perfect. And what's really funny is the degaussing coil is not even reconnected. It never has been the whole time. Therefore, this picture is not even degaussed, and yet, yeah, that looks really, really good. The entire problem since getting the vertical deflection working on this set was simply that 75 ohm termination resistor had gone to like 25 to 35K, so it was kind of open. And that was causing the video signal coming into the jungle IC to be way too hot. And on this particular jungle IC, it doesn't clamp the input level inside the chip. It just drives the cathode super hard. So even turning the screen all the way down resulted in, well, the image being all blown out like it was. And now it looks good. And in fact, what's really funny right now, and you can see that the on-screen displays look fine, you know, compared to the actual content of the picture. What's really amazing is I have the picture control, which of course is the overall image brightness all the way down, or almost all the way down. In fact, if you turn it all the way down, it still produces a really, really bright image. So this is really going to help save this CRT and not wear out this cathode, so that this TV will be, well, probably working well for a long time unless something else breaks. I think I'm ready to actually put this thing back together. I still can't believe it, but I think it's ready to go back together into the case, and then let's give it a final test run. Well, there it is. It's definitely 100% fully working. The TV is all fixed. Let me just turn the volume down on this. This is the NES game Shatterhand. And without a doubt, yep, this TV is working well now. So it was just that termination resistor. That was the final fault on this television. This certainly was a journey. Look at all this. Horizontal section, vertical section, notes on how to fix it. And over there next to my phone, there's a pile of bad parts and, well, stuff I took off the TV. And it has to say, the TV's definitely, yeah, it's working, I think, as well as it ever could have worked. It was always a cheap TV, so therefore content on screen, like bright spots and dark spots, result in deflection changes, especially on the horizontal side. But when you're playing games and stuff like this, you just don't really notice that. And it's really, to be honest, how all of these TVs were. These cheap TVs were just never that good at that stuff. That's why you buy PVMs. If you want to have really solid deflection no matter what you have on screen, you go with the PVM. If you want a bright picture that's vibrant and the TV is simple, well, then you go with one of these. So let's take a look at the stuff I've removed from the TV. So we have these 2/4 inch jacks. These obviously not a faulty part. This is just something that doesn't need to be on the side of the TV. Here we have a little pile of broken parts. So we had a blown up vertical deflection IC. That was definitely blown up. I just didn't notice it until we got to that. We had the original horizontal deflection transistor. So that was the one that was kind of faulty on the set when I first got it. It was causing the B+ to not come up. And then even when I tested it, it looked fine. But then if you put any kind of voltage on this, then it would go short. And then we had the second one that I installed that ended up getting cremated, and for whatever reason, not 100% sure yet. And really, there is the damper diode, which is right here. And I don't know if the damper diode was our problem that was causing those to get cremated. The video where I fixed the horizontal on the side just went live today. So it's quite possible that people in the comment section will be able to comment on whether this damper diode could have caused the issues with those. The other thing about this second transistor that got cremated is I changed the drive transformer, that little transformer. I put the one from the other parts board on here. I don't know if that caused the issue that cremated that one, the second one that is. But of course, that transformer and the second transistor were matched in the other set. So I'm not 100% sure about that. Something was causing that transistor to conduct too much current, which caused it to fail. And when we looked at the oscilloscope, remember, it was only getting like 220 volts. It wasn't getting to the 700 or 800 volts that needs to generate the proper horizontal deflection and the high voltage that the sets need. I also had a little capacitor here. I think this was something I changed, a little tiny one, at the beginning when I thought that was what was wrong with the power supply, why it wasn't starting up. That was before I figured out that there was a short on the B+. And then lastly, our failure was the tuner. For whatever reason, when I removed this from the board, because I had to, so I could change out the vertical deflection IC, when I put it back in, the set wouldn't even turn on anymore. So I'm assuming that whatever happened to this, maybe heat, for instance, when I was desoldering it, caused it to trash the I2C bus, and then the set wasn't able to communicate between the jungle IC and the microcontroller. And then lastly, the final problem was once everything was good with the deflection, horizontal and vertical, the image was way, way too bright, and it took me a little bit of time to figure out that it was a termination issue. And then the final two tiny little issues is there's a little scratch in the glass, a couple little scratches. They're pretty minor though, I have to say. They're not really bothersome when you're watching the TV. And it looks like the convergence is a little off. Horizontally, the red gun looks to be shifted just slightly to the right. And that's something that, you know, I don't know. I don't like adjusting those convergence rings, because once you do that, everything gets out of whack and everything is all reliant on everything else. You change one thing and 5 other things need to be adjusted. Overall, it's pretty good. And if you're going to be doing what I'm doing here, playing Nintendo games on it, it's totally fine. It is perfect for this use case. The Nintendo's low resolution. There's a low resolution TV. And it looks really good. It's vibrant, it's bright, and I still have the picture or the white level turned all the way to minimum. And yet it's super bright. So as I suspected by looking at the inside of this where there really wasn't any dust, I don't think this set was really used very much before someone started fiddling around with it. And really now we're left with the question is, what exactly caused this set to fail? Was it the fact that someone was running it without the horizontal and vertical deflection connected? Did that cause both the vertical and the horizontal IC to fail and potentially the damper diode? Maybe. If anyone has any thoughts of that, let me know. There's no burning on the screen. There's no dot or line burned into it. So it kind of makes me feel that whoever did that mod maybe did it after the fact, thinking that they could potentially do fun stuff with this TV. I don't know what's going on with that, and I don't think I'm ever going to know what's going on with that, not unless the original owner like pipes up and says, oh, this was me, I was trying to do this with it. Anyhow, there we go. That was quite the learning experience for me. I learned a lot about the inner workings of these cheap TVs, and that makes me confident that in the future, if I run into some of these that are broken as well, that I should be able to troubleshoot and get to the bottom of what's wrong with them. I said this before in the previous parts, but fixing this TV was really just an exercise in learning how to fix TVs for me. It really wasn't anything that I was trying to get this particular TV fixed, because as I kind of mentioned, this TV is really quite a boring TV. It's not that sharp. It's just not that good. The only saving grace for it is here in North America, you can find these TVs sometimes that have RF only, which is really scraping the bottom of the barrel. At least this one has composite video and audio. So it means it's useful at least for playing with game consoles and 8-bit computers and stuff like that. But really, it was just an exercise in learning for me, and hopefully for you as well. So if you watch this whole series, I hope there was some information in this that was useful to you. And if you're ever going to try to fix a monitor or a TV, 15 kilohertz monitors that is, it should all work in a very similar fashion to this. And hopefully some of the knowledge that you gained here and that I gained here will be useful for future repairs. The last thing I want to mention is don't be afraid to save parts boards. If you find old junk TVs that are sitting on the side of the road and are kind of destroyed, and you open it up and the PCB is in good shape, but the rest of the thing is trashed, take the PCB. Because as you just witnessed in this video series, all the repairs I did on this TV, all of them, was done using parts from scrap boards. This one is the one that gave both horizontal and vertical deflection ICs. This board provided me with the tuner that's in this TV now, and it also provided me with a 75 ohm termination resistor that is also on there. So really, if it wasn't for these two scrap boards that I had just laying around, well, I would have had to order parts or try to find parts, and maybe they were fake and all that stuff. And well, I know that the parts that came off these two boards were not fake, and that's why it's just excellent to have these scrap boards sitting around in a box, because there's plenty of other good parts I can steal off these boards in the future if I need to. So there we go. With that, we're done with this series, 4 parts in, and this TV is now fully working. I'll just add one more thing. I've been using this for a couple hours now, and it's still functional. Hasn't let the magic smoke out. And on the back of the set, it's just warm. I think this TV uses like 40 watts of power, so it's pretty power efficient, which is kind of amazing. So that's kind of cool. That's its one saving grace. So if you enjoyed this series, I'd appreciate a thumbs up. But if you didn't, you know exactly what to do. Huge thanks to my supporters, thanks to my subscribers, thanks to my members, thank you to all of you. Hit that subscribe button if you haven't already, and support the channel. There's links down below if you're interested in doing that. And comment down below on what you thought about this whole series, and I guess that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.